Hello, hello. This is Roberto, and this is the HVAC is my channel. Today we're going to be talking about total effective length and static pressure. Okay, this is part 13 of the two-story crawl second floor. Two-story crawl series of videos. All right, so let's get into it. And also, thanks so much for your support, because in the comments I saw that, hey, when are you posting the next video? And I appreciate that support. Okay, so let's get into it. Step number one, we're gonna make sure that everything is cleaned up. Okay, so I'm gonna be making another video after this that is gonna make a sanity check. So in other words, after everything is designed, we need to make sure that all the duct work, everything makes sense, like a QA/QC type of thing, quality assurance, quality everything, quality check, right? But that's gonna be for the next video. This time, let's just try to finish it up. And let's try to make sure that everything is consistent. Okay, so we're gonna go to the second floor. On the second floor, we have this, and honestly, sometimes the program plays glitches. So when it plays glitches, we need to adjust them. Okay, so in this case, what we have is the following. Number one, we have a closet in here. So in the closet, we're gonna have 3 CFM. 3 CFM is so little. It's not very good. On the other hand, we have two options for this bedroom. This is the master bedroom, and this is the closet. So for the master bedroom, we have 71 CFM, 71 CFM. We can make this closet part of the bedroom, so that way the CFM is gonna get distributed, right? So in other words, in here we're gonna have 45, 45, 45 maybe. However, the closet is their own independent room. The way you can do that is technically in the closet. Sometimes when it's a small closet, you don't need maybe supply register. You don't need airflow. You can just do transfer air. But however, in this closet, it's kind of a little bit bigger. The good thing about Wrightsoft is that you can always measure it, right? So this is going to be 7 feet 6 inches, and this is going to be 5 foot 6 inches. So you can always make the calculation of the square footage. This is going to be maybe 50 square feet. And then usually rule of thumb is like 1 CFM per square feet. So this might need a little bit of 50 CFM, 40 CFM. So there's a trick for that. Okay, because when you're doing the balancing, when you're trying to balance the airflow, you're not going to balance it to 3 CFM. That's nothing, pretty much. So I'm going to make a trick. I'm going to give it a load, a small load. So I'm going to go here. I'm going to put rooms, and then under appliances, see order. I'm going to put in here maybe, let's say 400, and see how much CFM it gives us. So for 400, it's going to give us 22 CFM at least, see? So depending on the manufacturer, depending on the home builder, sometimes they have a minimum requirement. Sometimes they say 20 CFM at least, this is the minimum. Other ones say 30 CFM. In commercial, we have 30 CFM minimum for ventilation. But in the federal government in the United States, they have a minimum requirement for 50 CFM. So in other words, we can leave it by 22 CFM, or even we can make it a little bit bigger, say 450. So, let's try. So this is 25 CFM. So that way it's more manageable, right? Okay, so number two. You're gonna ask me, so what a minute, Roberto, 25 CFM and you have a 26 by 10 supply riser. What's going on, right? So we're gonna go here to the ductulator. So this is the online ductulator. So in the online ductulator, we're going to check on this units. There you go, clear. So if in the ductulator, we're going to have 25 CFM. For 25 CFM, how much do I need? 25 CFM, and this is going to be 0.08 as friction rate. So let's put a 4 by 3 or 4 by 4. So 4 by 5, say 4 by 6, right? So you don't need a 26 by 10. So that's my point. You can always save on ductwork here. However, why is it giving me 26 by 10? Because this riser is accounting for all of the CFM coming for the first floor, right? So we're going to do that. We're going to check on the CFM. How much is the CFM in here? Riser duct. See, the heating and cooling ventilation is humongous. It's not 25 CFM, it's 1171.7 heating and cooling 11. So the design mode is heating. In the design mode, heating is 1171 CFM, right? So because it's sizing based on this CFM. However, you don't need this CFM for the closet. Look at the closet is 25 CFM and it was 3. That's not good. So what we're going to do is under the riser, we can always go to the riser. There's options. So in here we have automatic. Say if it's automatic, it was left like that. Practice this at home when you're with your program. Automatic, part of attached child duct, part of attached parent duct, separate duct. You can do with size change after takeoff. So we're gonna go for that. So with size change after takeoff, because if you leave it automatic, what's gonna happen is when you go to the fittings, look at this. This riser is coming from the crawl space to the second floor as one riser duct, same dimension, same everything. However, I don't want that. I want to change this. So what we're going to do is in here, riser duct, automatic, with size change after takeoff, put that. And then in here, we're going to put in here. See, it makes it different. So it makes it divides into two portions. So what I'm going to do in here is, oh, there you go. Look at my design mode, cooling. Look at the CFM. It's like 2.3 CFM. 2.8 CFM, which is so little, but it's still it's giving me 4 and 6. That's giving me by default. Okay, so let's press enter. There you go. Oh, but wait a minute. So now we're all good, right? We're all good. Actually, automatic sizing. What if I put yes? It's gonna give me same, right? Okay, 6x4. However, it's not showing in here. So this is going to confuse for the installer. If you leave it like this, oh, they're going to make it 26x10, which is not doable also for the walls. So what's going to happen in here is, there's a trick. Let's make this trick. See, if I move this to the side, nothing happens. Go undo, Control Z, undo, right? I'm going to erase this. I'm going to, and also I'm going to make another video of this, I guess, in my tips and tricks. I'm going to delete this, delete. I deleted this, and I'm going to create another one. Let's create another supply register right here for the closet alone. There we go. And then I'm gonna vary this. What I'm going to make this, I'm going to make right click and then register type. I'm going to go here to the high or low. This is going to be a low. Let's make a high wall grill. There we go. High wall register, because grill is for return. So high wall register, it's going to be go like this. Okay, so it's gonna make it like this. I'm going to rotate the angle. That's going to be 90 degrees. There we go. Another 90, maybe minus 90, because it's going to the other opposite way. There you go. Why? Because I need arrows. Default arrows, you put no. And then under the direction, we're going to put it like this. There we go. So I created a supply register, wall register, right? So now what I'm going to do is I'm going to connect this supply wall register to the riser. Let's connect it to the riser. I'm going to make this supply duct. There we go. Connected. Oh, it's giving it a dimension. There you go. Right? And look at this. Now my supply riser is showing 4x6, right? 4x6. Usually, don't get confused by 4x6. Is it height or width? Whenever you're in the field, you want to be very short or narrow on the wall side. Whatever is the narrowest, put it on the wall side. For example, in this on the wall will be 4 inches and the width will be 6. Okay? Okay, so now if I go to the first floor, oh, look at this. My riser is different, right? The size, I'm not liking this still, but we go to the first floor, we're good. But this is not going to have ductwork like that. So now what you're going to do is going to go here, just make it closer. Okay. Make it closer. It changed, right? So what we're going to do is going to go back. Go here. It's always trial and error, right? Let's go back. Let's go forward. Yeah, it changed it. No problem. See, what is my dimension in here? We're going to put delete. Oh, actually, it's good. Let's go here and hook it. Hook it back. Still showing me this. I'm not liking that. Delete. There you go. Oh, these glitches, right? Okay. Let's go here. Supply duct. Go here. Bear with me. Oh, it's not doing anything. So what I'm going to do in here is, again, do the following. So see, that's what we have to do sometimes as designers. We have to deal with that. 10x6, 25 CFM, that's all good. Oh, because it's my connection points. Let's go check on the connection points right here. Go here. Okay, maybe that's why it's not connecting. Let's uncheck this. I'm gonna go here and then return. Where's the supply duct? Supply duct. Let's connect it. It's not connecting. Let me try and verify this. So I'm doing this live always. So what I'm gonna do in here, when that happens, oh, wait a minute. Let's do this. Okay, that's good. I'm gonna have to do this again. Okay, so we're gonna go delete. Yes. Okay, so I'm gonna go here and then do that again. So there's the supply register, create. It's a quick process again. Sometimes that happens. Go here and then register type, high wall register. Go here, rotate it minus 90 degrees. We're rotating it and I want default arrows. Yes, no, airflows. This goes. It's just the same process. Now, for this side, I'm going to connect this with the supply register. No, with the supply duct. Supply duct, click here, and then now here, connect. There we go. Wow, it's not connecting. What's going on? Well, what we're going to do in here, let's try it again. So what happens in here is actually, it's connecting now. Let's go again. I'm connecting it. Let's connect it again. So I was playing with this a little bit. So what's going on is this is not set under automatic sizing. See, if I go here, right click, it says in here, automatic sizing, no. So if I put in here, yes, we go here, there we go. It says like 4 by 10. 4 by 10 for 25 CFM, I don't agree. So what we're gonna do in here is let's change this for 6. There we go, my velocity is still high. There we go. So 4 by 6, 4 by 6. Let's leave it like that. Okay, so now we go here, go here, go here, go here. Let's get closer. There we go. Now for the graphics. Okay, for the graphics, what we can do in here, there's another trick. So I'm gonna go to drawing options, grid settings. I'm gonna put it by 3. You don't need to make this 3 by 3 because I changed it before. I'm gonna make it closer. Let's see. There we go. That's the closest it can go. So I'm gonna go back in here. I'm gonna put my grids to 6 by 6. There we go. 6 by 6, 6 by 6, 6 by 6. Okay. So we're done with this part. See? Okay, so we have 25 CFM, we have the 4 by 6, and then you can always add a note in here, just connection depending on the field conditions or something like that. But my supply riser now it's like 6 by 4 or 4 by 6. Okay, so with the closet we're totally fine. Now another thing I realized is like there is no return on the second floor. There has to be a return. Okay, so I'm gonna add a return side in here. So let's put a return grill, supply register. This is a return grill. Usually this goes on the hallway. So that's the hallway, and the hallway, what I'm gonna do is again, register type. We're gonna put, in this case, high wall grill right here. Let's put that, high wall grill is like that. And I'm gonna rotate the angle minus 90 degrees. No, it doesn't work, minus 180. There we go. Now default arrows, we're gonna put no. And then we have arrows, we're gonna go inside. Nice. Okay, so technically now we have this total amount of CFM. If I click in here, you can see that all my second floor is included here. All my supply registers are going to go directly to this return grill. Okay, but this return grill is going to be connected right here on the hallway, but it has to be connected to the equipment. So let's go check on the first floor, but you also have to make sure that you're saving it, right? Imagine that you completed your project, and that happened to me many times when I finished my whole design and everything, and almost at the end before printing, a glitch happened. So I had to redo everything again. So that's why it's a very good idea just to save always. Okay, so if we go to the first floor, see, we go to the first floor, we have in here we have a riser, see, return riser. We have a riser right there. So what I'm gonna do is, this is coming from the crawl space. From the crawl space, this is the riser, right? Okay, but now this riser is not gonna be round. Usually it's rectangular because you have more flexibility with rectangular ducts, okay? All right, so let's make this rectangular. So let's go here. To make it rectangular, you're gonna add height. Let's put a height, say, for example, like 10. What happens in here? 10 by nothing in here, it says. Let's go connect this. There we go. Oh, it's giving me trouble. No problem. You know what's the issue in here? Connecting. The issue is like, see, it's still giving me this. Maybe the grids, because I changed my grid settings. I'm gonna go back to 3 by 3 by 3. That's how I started, right? There we go. So I'm gonna go change it again to, say, 8. Yeah, 22 by 8. Look at this. Oh my gosh. 22 by 8. Oh, everything's 22 by 8. So this riser is not going to be round at all. If you're doing a riser that is round or what has to be round, you can do oval, but not round. 14 inches. Which architect is going to give you 14 inches of riser, right? So now we're going to go here, riser, and then this is 14 inches. Instead of 14 inches, where are you? Diameter. So in here, we're going to put width 8. There you go. It's 16 by 8. Okay, but wait a minute. In here it says 22 by 8. It goes here 18 by 8. That's interesting. Yeah, maybe on the next video we're gonna make a deeper analysis. But as of now, I wanted to show the layout. Okay, so 12 by 8, 16 by 8. Okay, we go to the first floor. Now, on the first floor we have 16 by 8, right? You know what? I'm gonna do again the same process. This is 697. I'm going to detach this, delete. Okay, and I'm gonna create another one again. So return grill, make it in here, code area. There we go. So in here in the code area, I'm gonna go change this to floor 2-way. This is in the floor. Let's put a high wall grill, and then this is default arrows, no. Where is it? Default arrows, no. And then under no, we're gonna put directions, none, yes, this guy right there. And then we're going to rotate it minus 180. Here we go. Okay, so now what I'm gonna do is, let's make sure that this is connected to all of them. See, this is collecting all the return from these registers. If we go to the second floor, this return grill is collecting the CFM of all these supply registers. There we go. So we're all good on this. Now I'm going to make the connections, but we need to clean up the risers a little bit. See, my riser doesn't go up to the second floor. It should go to the second floor because this return has to go to my main mechanical system. So I'm gonna go to the first floor just for the sake of connecting. So go to the riser, click on the riser, right click, and in here it says in the fittings, crawl space to first floor, we're gonna change it to the second floor. There we go. Now this goes directly to the second floor. In the second floor, let's see where it lands. It lands right here. I'm not liking it. I'm gonna make it a little bit back. There we go. See? Closet, it's right at the corner. And anyways, I think the video was, I had to make a little bit of an edit because the video was getting a little bit longer. So what I did is actually, let's review this. So see, the riser is going to be in here 18 by 6. So what happens is we were going to here to the PDF. So see in the PDF, we have the mechanical, we have the closet, and we have a chase. So in the chase, We go here, and if we go to the first floor, see, now it's connected to in the mechanical closet. See, it's in the mechanical closet, and then we have the supply riser right here. So in other words, everything's looking good now. We focused a lot in the closet, but now my return, it's connected to everything. See, and it's 486 CFM, 14 by 14. That's the connection. See, this is my supply, my return riser, and then we're gonna go to the first floor, and this is again, I mean, this is 14, but you can always change it, right? So in here, if you give it dimensions, it's going to change it automatically to rectangular, right? So this is connected to the riser, so they have different dimensions. As you can see in here, it's 20 by 12, and then in here is 18 by 6. Let's make this very quick, more consistent. So this is going to be 20 by 12. You only want to change one dimension. So in here is 18 by 6. In here is 12 by 8. Not 20 by 12. So what we're gonna make, let's make, what if I put this instead of 20, let's put 18. So if I put 18, this is gonna give you 18 by 12. So let's make it 18 by 14. There we go. So it's less velocity, right? So this is gonna be 18 by 14, and then when we go up, it's 18 by 6. See, it changes a lot. Okay, but only in one dimension. So when we're going to go to the crawl space, see, it is 18 by 14. Let's go check. This 18 by 14, 18 by 14. So 18 by 14, there we go. And then we connect here. What is this right now? Oh, this is 20 by 12. It's collecting everything from everywhere. Okay, 20 by 12. So now we're all connected. As you can see, we're all connected. I already did make a sanity check in here. So 20 by 8. And then on the first floor, the riser goes here, and it goes up to the bulkhead. This is the bulkhead. See, 8 by 6. 8 by 6. And also for the bulkhead, very quickly, what I want to do in here is also put a text. In the text, I'm going to put the dimensions. Usually the architect asks, hey, what's the bulkhead? So we're going to put bulkhead. See, what are the dimensions of the bulkhead? Please leave in the comments if you have any input about the bulkhead. How much clearance do you leave to your ducts? So in my duct, since it's in the conditioned space, it doesn't have it's not going to have insulation. However, I'm going to put in here 8 by 6. I'm going to give it a clearance of 1.5 inches on all sides. So if it's 8.5 inches, since it's two sides, for example, this is the width and this is the height. On the width, this is 8. So if it's 8, you're going to have 1.5 inches on this side and 1.5 inches on the other side. So that is 1.5 plus 1.5 is 3. So you just need to add 3 inches to each side. 8 plus 3, that would be 11. 11 by 6 plus 3, that would be 9. Right? And you know what? If you want to be conservative, why don't you give it maybe 12 by 10? There you go. Okay, my bulkhead is going to be 12 by 10, you can say to the architect. And the architect is going to coordinate with you. Wait a minute, that's a big, or that's, make it a smaller, something like that, right? Okay, now we have completed everything. And then I had to cut the video because it was getting longer. But however, also the video is mainly about the total external static pressure. So what I'm going to go is going to go to duct design, static pressure. So under static pressure, we have the coil. We're estimating a 0.2 of pressure loss, and the filter is 0.15. And look at this friction rate is not looking good, 0.046, right? So the reason is about the connections. Okay, so we're going to go to that point. So what happens in here is the following. Okay, when you go analyze the duct design and you're going to go to the static pressure, this is the critical path. It's not all of them, it's just the critical path. If you go to the critical path in here, right click, go ducts, it says thin line for supply branch. No, show longest run ducts as thickest. Yes, and then click enter. There we go. It's going to show you what's the critical path. The critical path on the return is going to be the return riser. There we go. Return riser first floor, return riser second floor, and then the crawl space. See, the return riser See, all of this is the critical path. And what is that critical path dimension? Okay, so we're going to go here, return. This is 160. 160. Let's check on this. 160. Okay, all of these equivalent lengths fittings. Those are the ones. Okay, what about the supply? The supply is giving me more equivalent length. So technically, we need to reduce the equivalent length, right? So it's 350 feet. Oh, look at this. 9B1 is the one that is giving me at least 80. 9B1 is 80. Okay, analyze what is 9B1. 9B1 is going to be the following. Let's go check in here. 9B1. What is this? Go here. Go here. Let's go check on the type of 9B1 fitting. Okay, this is giving me 80. So what we're going to do in here is let's lower it to this, to 9B2. Okay, right? There we go. And then go here. Okay, so what's going on in here? Let's go check again. Here, duct design, static pressure. So now it's like 0.53. So look at this, how much changed, right? So now we have 5555. We have another 9B1. So let's go check and find out 9B1. So we're going to go find this 9B1. It's going to be maybe on this first floor, second floor. What's my critical path now? There you go. See all of this. What is this? 9B1, 9B2. Okay, what's this guy right here? 9B1. Oh, we have a lot actually. So 9B1, we're just going to make it a straight T. There you go. Straight T. And you see but now let's check on the drawings and then the static pressure. And you can also do the other one. See, the shortcut is Control I. Let's go here. Still giving me a headache. So let's go here. Let's go changing this. Put it in B2. Let's go here. Put it in B2. Okay. Put it in here. What's this now? B1. Put it in B2. Trunk, rectangular branch trunk. Okay. Okay. Let's go here. Okay. And then B2, okay, and then let's go changing here, B2, okay. We're doing it all at once. See, let's go here. And again, you know what? It's a very good idea to have someone to check your work at the end of the day, because then that's a very good design. Usually, as in my experience, that's what we do in the field. Okay, so static pressure, see. 0.057, right? Okay, so in here we're good. Now we're gonna go to the first floor. Oh, look at this. Why is this not connecting very well? You know what I'm gonna do in here? Why is not doing anything? So we're gonna go connect it back. So the reason is why it's not connecting. This is 6 inches. This is gonna go to the first floor. Okay, 6 inches. So if it's 6 inches, oh, because this is 8x4, right? We're gonna increase the size of this. We're gonna making it 8x6. Okay, what about 8x8? Okay, why is not connecting? Let's go back. Let's go back. 8x6. It was 8x6, I guess. Or 8x8. Let's put 8x8. See. Okay, so why is not connecting? Oh, no. It's connecting. It's just this is now my critical path. This is the longest run now. Okay, let's go here. Oh, now in here, let's go check in here. 6B1. 6B1, we're good. Okay, so let's go check on my visit. Control I. Control I is going to take us directly here. So in here we have, this is 100 equivalent length. So this is 2I4. 2I4. Let's go to 2I4, but this is in my critical path. This is my critical path of supply. What is 2I4? Critical path in here, 2I4. This is 2I4. right? And this is giving me 100 feet of equivalent length. Let's put in here at least, let's put in here this and see how it goes. What is this giving me? This is giving me a static pressure of 0.7. Now let's focus on the return side. So on the return side, we have this. Okay, this is equivalent length. We're gonna go again. So we're still playing, you know, we wanna make sure that we have enough TEL. But you might be wondering, in the field, you need to make sure that this is real, because in papers you can change anything, right? But in the field, you're gonna make sure. But when you have, in the field, when you have your equipment, you have tabs, right? You have tabs, tab 1, tab 2 to increase the CFM or decrease the CFM. So you have to play a little bit more with the field adjustments. We can talk about that in other videos. So technically, if I put a small filter in here, see, it would pass, right? So let's put a filter in here of 0.13, see? With 0.13, we're passing. Let's put 0.10, no, 0.14. 0.14, no, it doesn't pass, 0.13. There we go. So it passes, okay, passes. And as I was mentioning though, number one, you always need to make sure to let the customer know that your filter has to be clean. They have to change it very well, because if the filter goes dirty, that increases the static pressure, right? Based on my system design, it wouldn't be a good idea. Number one. Number two, see, the static pressure is 0.70. This external static pressure is related also to the equipment. So in the equipment, when you go here, you have a certain amount of CFM right here, right? So if you go to the static pressure and CFM curve, you can find out what CFM you need, what tab you need, or how this works, right? So that's why I was changing in the paper. It could work, so technically you're gonna pass, right? It passed, but in the field it might not pass, right? In the reality, you want to provide very good customer service, so you need to play with those in the field, with those numbers, and the installation too. All right, you can also find out different ways to maybe reduce ductwork or something like that. All right, well, I hope you enjoyed this video, and then in the next video, we're gonna be making the print out, and also we're going to be making a final check. All right, thanks so much for your support, and then leave any comment, and I appreciate your comments that indicated, hey, when is the next video coming up? And that really reminded me, hey, wait a minute, I should be making videos actually. All right, thanks so much, and I'll see you in the next video.